So let's start today's session. My name is Amit Pandey, and I would be an instructor for this session, as well as for the upcoming GCP session as well. Right. So, guys, this is a very short introduction about myself. Right. These are some of the certificates that I hold. Just let me share the screening. Yes. So these are, guys, some of the certificates I hold in multiple domains from, uh, security, from offensive, from defensive, and multiple other different cloud platform, from AWS to the Azure to the GCP as well. Right. And I have more than 5 years of an experience into this particular field of cybersecurity and cloud security. Okay. Let's talk about the organization InfoSec Train. InfoSec Train, guys, was established in 2016, and they provide certificate trainings, to our clients across the globe in multiple different domains. From whether it's cloud pen testing, whether it's mobile pen testing, whether it's a SOC analyst, whatsoever it is, it's been delivered by the InfoSec Train. And these are some of the endorsements. We have the pool of more than 70 uh, specialized trainers which are having a expertise and a specialization in their respective domain, whether it's cloud, whether it's mobile pen testing, whether it's CISO, whatsoever it is. Fine. And we offer more than 200 courses. Clear. Now, these are some of the trusted clients we have in place. We have Tata Communication, Indian Air Force, and SBI, State Bank of India, one of the India's largest public lending bank, is one of the clients. Okay. So why should anyone should do an training with the InfoSec train? So in that particular case, you get flexible mode of training, whether you want the training respectively on the weekends or in your respective weekdays, you get that particular training. And there's another thing, you have this access to the recorded session, like same way this particular session is recorded, and the recorded sessions within a day or two would be delivered in the respective YouTube channel. So if, let's say, for example, you missed any topic, you want to revise anything, you can go to a respective YouTube channel, and within a day or two or three, this particular sessions would be uploaded there. Clear? Okay. And when it comes to any kind of a course you are joining it up with the InfoSec train, within the day or two, you receive it over your respective registered email address, which you can revise it up to just boost up your respective learning, right? And then there is post-training completion. This means that, guys, once your respective training has been completed, irrespective of which kind of domain it is, whether it's cloud security or pen testing or whatever it means that you still make up a connection with that particular trainer. We generally make up a Telegram group or a WhatsApp group, and in that particular group, that group still maintain intact even after a respective course has been completed. Fine. So if, let's say, for example, you have respectively completed your course of the GCP or one of the certificates, then you want a guidance from the trainer that what should I do after this, right? To get up a boost in my respective career. Should I go to the cloud pen testing? Should I go to the another vendor in place? So you can call to the, or you can message to the respective trainer, and he'll be guiding you in that particular case. That's called the post training completion. Clear? Okay, great. So, guys, as this particular webinar has been fragmented into four parts, today is the first day, and these are some of the topics, guys, we will be discussing it up. The introduction to the cloud, that what actually cloud is. Then we are going to talk about what is cloud computing. I see that many people really get confused into what's cloud and cloud computing. That's a little bit of a difference is there. We're going to discuss that as well. Then there is cloud, different kind of vendors we have. What are the top three vendors? Because see, if you go to the market, there are hundreds of vendors, but we will be sticking with the top three vendors, fine, which is changing and shaping the particular cloud environment across the globe. Then we have cloud deployment models. What are the different kind of deployment models we have in place? And then the cloud service models. And then there's a very important thing when you are dealing in the cloud, whether it's which irrespective of the vendor, you have something which is called service level agreement, which gives you a little bit of a clarity that who, when that particular job role is of the cloud vendor or that particular responsibility is yours. That's what we learn at the service level agreement. Great. So, guys, let's start with today's session. The first is introduction to the cloud. What is actually a cloud? So, cloud means, guys, in a short and a very limited language, cloud means someone else's computer. Fine. That's what a cloud is. Okay. Cloud means someone else's computer. Okay, let me just give you an example of the cloud. The best example is the Google Drive. Before jumping into these kind of complicated public cloud like the AWS, Azure, or the GCP, right? Let me just take you to the very basic one which we use it up every single day. The one is the Google Drive. Okay, Google Drive is also a perfect example of the cloud, right? You have a particular piece of an information, you can dump it over the Google Drive, no problem with that. Fine. Okay, but remember that particular Google Drive is hosted over a physical server. Do you have a control over that? Do you have a control over that particular machine where the Google Drive is stored? No, right? Your particular piece of data is lying over someone else's server or PC, right? And you do not have any sort of a control over that particular machine. That particular machine can be present in any part of the world, right? So that particular server where your particular data is kept, let's say for example, I have a very sensitive data or a movie or a pictures, and I do not want it to keep it in my local system. Multiple reasons could be there, like the capacity could be the reason. I can lose the access of the data. I can face up a cyber attack. That particular scenario, what I do is that I transport the data or I upload the data to a Google Drive. Correct? Now, whenever I upload the data to the respective Google Drive, what happens in this particular case? As you can see by the diagram, just give me a minute and let me grab the pen. Right here, you can see that from my respective laptop, the data is being transported to this particular machine. Fine. Okay. And do I hold this particular machine, or do I am the owner of this particular machine? No, Google is. In the case of the Google Drive, whenever you're uploading up a piece of an information, it has been going to the Google Drive, right? And Google Drive is storing that particular actually in the backend or hardware or piece of an hardware which is managed by the Google. Okay, but there are some problems with that as well. One of the biggest problem, you can see it up, this particular PC or the laptop or the owner could be a different part of the world. Right now I'm in India. This particular server where my actual data is present, it could be in any different part of the world. It could be in Japan, it could be in Saudi, it could be in United States, it could be in France, it could be anywhere. And the problem in that particular scenario is that whichever country this particular physical server is present, that country's laws and regulations apply to this respective server. That's the catch. Okay, so that's the problem we will be talking about as well as we progress ahead in today's session. We will be talking about the pro and cons of the cloud part, but you get up an idea that what is actually a cloud. Cloud means nothing, someone else's computer. This, guys, is a cloud. Okay, so from now onwards, anyone says, we are switching to the cloud or something like that. Cloud means actually there is a physical server which is owned by some company, which could be Amazon, Google, Azure, right, or the Microsoft, anyone, and your data is present there, and they will be protecting your respective data through encryption, through physical security, all this kind of thing, different things. Fine. That is what's called the cloud. Someone else computer, right? Or someone else machine. Fine. Okay, great. Now there is another term, guys. After the cloud, there is another term which is called by the name of cloud computing. So, guys, what comes to your mind when we say about the cloud computing? What is actually cloud computing? Cloud, we got an idea, right? That what it is. Cloud means someone else computer where you're putting up the data, like the Google Drive. Whenever you are uploading up the data in the Google Drive, actually what happens is that that particular data is stored physically over a server of the Google. Fine, that's the case. So what is actually this computing? What is actually this term combined together cloud computing is? Let's break it down. This particular word, cloud computing. What we will do in this particular case is that cloud means what? Cloud means that's a feature. I would say that's the feature of the cloud we have, right? Okay, but I'm saying in a very layman's language, how would you define cloud computing, right? So cloud means someone else server. This is my server, and now what I'm doing is that I'm making it public, so you guys can put your respective file inside this particular server. So I would say that's a cloud, right? A particular piece of a machine which I have rented. You does not own it. You have just rented it up. So let's say, for example, you want to put up a file in this particular, my server for 5 days, 6 days. Okay, fine with that. So for 5 or 6 days, your data is lying in my respective server. Okay, now it's my responsibility to protect the data physically, to and I need to use a good security mechanism in place in order to, if there is any kind of a cyber attack, what happens is that your particular system does not get compromised. Fine, those kind of things. So you are what you are for 5 or 6 or 7 days putting up the data in the respective where in the respective server. Clear? So you're renting it up. You does not own that particular physical piece of an hardware. You are putting up the data for a temporary period of time. And let's say, for example, the data was present there for 7 or 6 days. In that particular case, what's the catch? You are paying for that particular duration for 7 days, for 8 days in place. Fine? Okay, great. So that's the thing with the cloud part. You are renting the stuff. You're not owning up anything. You're just renting up a stuff. That's the reason that when you go to the cloud part, the hardware, the functions, what you have received is so cheap because you rent stuff. You do not own them up. Okay. Then comes the another segment, which is called the computing part. What is this computing part? Computing part means that this particular server where you are storing up your respective important files, this can do, guys, the complex calculation. That is called the computing. Okay, just let me just give you an example of the computing part. Uh, we have all heard about the Google Drive, right? So in the Google Drive, guys, generally why we use the Google Drive? To store the data, right? We what just take it up, absolutely, Milan, right? We have a particular piece of an information or a piece of a file or any kind of thing. We dump it over the Google Drive. Clear? Okay, great. So at any point in time, if I have good internet connectivity, I can fetch the data from that particular Google Drive as well, right? At any point in time. That's a great advantage I have in place, which is fantastic. Okay. Now, in that particular case, the problem here is that, guys, tell me. So, Google Drive is definitely for sure a cloud, but let's check whether the Google Cloud is a cloud computing. So, in cloud computing, that particular piece of a server can not only store the data but can also do the complex calculation. So, guys, if let's say, for example, let me just draw it, erase it up. Let's say this is the server of the Google, right? Where Google Drive actually put up your respective data. If I just say it up that provide me the sum of 2 by 2, do you think that the Google Drive would be able to provide me the answer of it? Do you think that the Google Drive would be able to do the calculation of 2 by 2? No, it will not. It is just there for storing the data. That's why the Google Drive, guys, is a cloud. Cloud computing means that that particular piece of a server which can do the complex calculation. Fine. That's in the particular, I would say, in the cloud environment. When we go, we have EC2, right? So you just give it up a assignment. You just like same thing like the prompting. You say that, okay, I want to deploy up a server with this respective configuration. As we move ahead, and tomorrow session I will be explaining you that how to create up a server in the GCP. Okay, that kind of thing. So as we move ahead in the session, at that what happens is that you just need to specify the templates, the details, that okay, I want a server in this particular geographical location, this is the configuration, this much is the hardware, this is the thing, right? And what happens is that that particular piece of that particular resource, what it does is that it creates up the server as per your respective requirement given. Okay, that is what called the cloud computing. It means that that particular server which can do this complex calculation and give you the output. It's not just uh, we are sticking with the mathematical complications. It could be anything. Like another example of the cloud computing I can give you is your chat GPT, okay, or Bard as well. Okay, what happens in that particular case is that you just give it up a task to the chat GPT that okay, write up a script or do this or do that or write up a program or in a Java or Go or Python or whatever it is. Then what happens in that particular case is that that particular program write a piece of a code. Okay, that is what it's the cloud computing. You're not just storing the data and fetching it out in that particular chat GPT. You are assigning up a respective task, and that particular task, complex task, that particular chat GPT is able to perform it up. That's called the cloud computing. When the server is able to do the complex calculation and give you a good result, that is called the cloud computing. So there are a lot of applications of the cloud computing nowadays. Many organizations are going for this cloud computing, and specifically the gaming industry, right? So what happened in that particular case is that as I have written in this particular case, as you can see, Stadia, which was the project of Google, and there is another project going on which is Xbox Cloud Gaming. right? What happens in that particular case is that why gaming industry, this billion-dollar industry across the globe, and these tech giants, whether it's Xbox or it's PlayStation or the Stadia or Nintendo, right? Why they are switching to the cloud? Why they are switching for the cloud computing? Okay, the problem with the gaming industry is that your game is not, is kind of specific to the machine you're running in. Let's say for example, if I spend today hundred or thousands of dollars to bring up a particular machine, fine, okay, thousands of dollars spend it up to purchase up a particular laptop which is specific to the gaming, okay, or to a respective console, fine. Now what happens in that particular case, guys, is that now if the latest game today in May, the latest game would be running in this particular $1,000 console. But what happens is that the gaming industry is changing it up. They are using up some high-end technologies in the back end, okay, to just bring, just make it much more great experience to, and so that you can able to play that respective game. So let's say for example, after 6 months, a game comes into it, and now that particular game which comes after 6 months is not able to run as smooth, right, in that hundred, in this $1,000 particular console. Then you have to again purchase up a $2,000 console in place. So you see the game are advancing, but your console is not. It just doesn't make up a sense for a normal user that every month or every 6 months he brings up a console. Generally what I have seen is that, or generally what happens is that the buyer purchases up a console and now he is going to stick with that for at least 3 to 4 years, fine, but the games are becoming much more advanced. That is kind of a limitation these game developers think is. So what happens in that particular case is that when you go to the cloud computing, things changes into it. Let's say for example, I have a very low end particular PC which has, let's say for example, i3 7 generation, very low one, and 4 GB of RAM. Definitely for sure, if I want to run today's latest game into this particular system, it's not possible. Immediately, I will be getting up an error that this does not fulfill the system requirement to run that particular application or the games. Fine. But once you move to the cloud computing, what happens is that this limitation, hardware limitation, is gone. In that particular case, what will happen is that this is particularly my PC, and there what happens, there would be a server running in the Google or the Amazon or somewhere else, which will be running up the game on my behalf. Fine. So what will happen? I'm renting it up. Let's say, for example, I want to play a game. So what I will do in that particular case is that for my PC, I will be sending up a command to that particular server, we are connected through the internet, and then when that particular piece of the information runs over that particular server which is hosted, which is present in Google physical data centers or in the Microsoft data centers in place, and that particular character changes its activity, and I get up a response. Fine. That is what Stadia and Xbox gaming was all about. That you are moving, when you switch to the cloud computing, you are eliminating this particular problem of hardware limitations. Clear? That's the case. That's why so big organizations are switching to the cloud computing, because in that particular case the weightage upon the end user, the system requirement, is completely eliminated. Fine. It doesn't matter that even if I just want to play up a very high end game for which I have to purchase $2,000 of a laptop, I if I go for the cloud computing, what happens that particular case is that that particular piece of case does not run locally over my system. It runs over the server. I just, through the internet, I'm connected to that particular server, so I can make up an interaction with that particular character. Clear? That's the power of the cloud computing. Okay, great. Now let's talk about, guys, the advantages of the cloud computing. Definitely, for sure, whenever you are learning about any kind of growing industry, you should be aware about the advantages and the disadvantages. So we are starting with the advantages, and after this we are going to talk about what are the disadvantages, what's the problem with the cloud computing. Okay, but let's start with the advantages. Fine. One of the advantages is cost effectiveness, right? One of the biggest advantage of the cloud computing is, guys, cost effective. It's cost effectiveness. It's cheap. Why it is cheap? Because what happens in the cloud platform is that you are renting the stuff. First thing, let's say for example, I would say one of the biggest reason what my many of the organizations nowadays are switching to the cloud platform, or even the hospitals or big corporate organizations are, even if spending millions of dollars to create up a cloud platform, what they are doing is that they are moving or renting up a cloud platform. Why they are doing so? Instead of creating their own architecture, why they are going to these AWS, Azure, or the GCP? In that particular case, why they're doing that? Let's say, for example, you want to purchase up a server. The cost of the server is, let's say, it's $1,000. Clear? An actual server, I would say. Great. So, guys, tell me if I want to create up a local cloud, right? Or a cloud inside my organization, a private cloud, just buying up a server is enough. I go to a respective vendor and I just purchase up a server, and now my cloud is set up. I'm good to go. No, right? We do not. We need a dedicated team for that. And definitely for sure that again raise up the call. Let's say for example that specialized people who would be protecting, configuring the resources of your or that particular server, right? That should be again $100,000 you have in place. Then you have to physical security because when you are building up the data center or holding up a server actually in your on premises, then what happens in that particular case is that you know in that particular case you have to create up a environment where you will be controlling up the temperature, where you will be controlling up the humidity and all these kind of things in place, fine, those kind of things. So you see that initial cost, upfront cost we have in place. Upfront cost means that guys you have to pay before even utilizing that particular resource. There is a initial investment that you need to do, that is an upfront cost. Clear? So even if you want to use this particular server and all this kind of infrastructure, you at an initially you have to invest $3,000. Okay. Then this particular server would be purchased, set up, configured, and then it is now ready after spending $3,000. You it is now eligible that it can be used up. Okay, that's the case. So that's the thing with the on-premises part. But when guys, when you move to the cloud part, what happened in that particular case is that you are going from $3,000 to, just wait a minute, you're going from $3,000 to, I would say, $20, right? You are just moving from $3,000 to $20. That exact same hardware configuration server, I can rent it up, run it, and share with my respective client, run up my respective application for 7 days, for 8 days, all this kind of things. And the cost that I will be paying for would be hardly $20, $30. That's it. And after that, what I will be doing is I will be completely, guys, dumping this server. Okay, which is not is the case when it comes to the on-premises one. So in this particular case, see, I have on the on-premises one, I have invested $3,000, and now this particular server is there. There is something which is called end of life, EOL. Guys, any idea what is an end of life is? The best example, if I just want to tell you of the end of the life, or every product, every like the human being, we have a particular life cycle from the birth to the death. The same way every product, hardware or software has a life cycle which is called, okay, that particular life cycle we have. The ending phase, the last phase, when that particular device or the software and the manufacturer has made up a statement, and now onwards they will not be publishing up anything in place, any kind of an update and anything like that. In that particular case, what happens is that we say that particular that server or a system is now a legacy system. So now guys, that is also a big limitation when it comes to the on premises one, because in the on premises one the problem is that you just go it up, you have spent almost $3 to $4,000 over a piece of a server, one single server I'm talking about. Then you have a team to manage and all this kind of stuff in place, fine. Then normally what happens seen is that the limitation is 5 to 6 to 7 years is the life of a server. After 7 years, this particular investment that you have made it up to this particular server is gone. Now this piece of a server, this piece of an hardware which is so expensive is of no use, because after 7 years the manufacturer is going to raise his hand and say, you know what, I'm not going to provide any kind of an update to it. Okay, the best example of an end of life I would say is Windows XP. Fine. So guys, tell me what's the problem of using up a legacy system? If I still use Windows XP, or there used to be a phone which is called by the name of Nokia Lumia. Guys, remember that? Way back in 2010 and 11, it was a huge thing that a Windows phone is there. which will be taking up the market, but it was a complete failed experiment by the Microsoft and Nokia. So 2016, Microsoft made up a statement that from 2016 onwards, they will not be providing up any kind of a security update or a patch to that legacy system or to that particular system. And from that day onward, that particular Nokia Lumia Complete series becomes up a legacy system. Okay, great. So guys, what's the problem of using up a legacy system? What's wrong with that? You have a server, you have invested into it, you have a team which is configuring it up. What's the problem with that? So vulnerability is there. That's a big problem. Because let's say, for example, today I also have hold that Nokia Lumia, which is a legacy system. But the catch in that particular case, guys, is that in that particular phone, I store any sensitive information, my credit card information, my debit card information, any kind of information I put into it. But the problem here is that if there is a vulnerability, because the manufacturer has already raised up the hand that now he's not going to provide any kind of a patch, so what happens, there is lot of loopholes that has accumulated over these years into that particular piece of a machine, so now it's prone to attackers, right? So if I still use up a legacy system, either it's my personal device or inside my organization like a server, even if I've spent thousands of dollars into setting up, purchasing up, maintaining that particular server, okay, and the environment as well, because a lot of investment is also made upon this, I would say, ecosystem. When you're creating up a particular server or data centers, you have to spend up a lot into creating up a a kind of an environment where you can control the temperature and all this kind of thing, because then even a small little particle dust can ruin your data centers, so you have to create up a very controlled environment, and that is demands a huge amount of investment. Okay, so even that's the case, if let's say for example still I use up a server, what happens in that particular case is that I am inviting the attackers. What will happen is that the particular one, the legacy system, the legacy server would be having hundreds of vulnerability, and the attackers would be loving it, right? They will be approaching to my respective server and doing what? Then hacking into it, stealing my sensitive information, and that would be a nightmare for me. And remember, whenever a respective organization face up and hack, there are sort of problems they face. There is a reputational loss, right? There is finance loss. The customer goes away. So a lot of problems that particular organization face, but still I've seen many organizations, they still stick with this legacy system because it's quite cheaper for them. Okay, that's the case. So these are the problems when you go into and creating up an on-premises infrastructure, a physical infrastructure, creating it up for your own organization. Yes, it has its own benefits, but the it has a lot of problems as well. But when you switch to the cloud, these all of the problems are eliminated. There is no upfront cost. You does not need to pay thousands of dollars for this your particular Google servers. Okay, you need that particular server. You create it right now. That particular server runs for your respective uh, slot. Okay, and after that you completely remove that respective server. That's it. There is no upfront investment into it. You do not need to pay a single penny to the any kind of a any kind of a cloud provider, whether it's a GCP or the AWS or the Azure. As in this entire session, we're going to stick with the GCP. So GCP as well also will not be, you will not be paying up any kind of an upfront cost. Okay, that's a very great thing here we have with the cloud part. Another thing with the cloud part is that with this particular whenever you move to the cloud part is that there is nothing you are owning it up, because when you own something, when you own up a server, there is a problem of what, a legacy system, that after 5 years, 6 years, 7 years, what happens in that particular case is that that particular server is now what, you have to retire it up, right, and go again and spend thousands of dollars and purchase up a new server in place. That's a thing we have. Fine. But when you have in the cloud, there is nothing, particularly in the GCP, that or in any kind of a provider, there is nothing as called as a legacy system. It's not your headache. Fine. That the backend server is now up legacy system or it's not up to date. It's the responsibility of the cloud provider. Okay. So I can go to the GCP, deploy up a server, run my application for a month, 6 or 7 or 1 year. I pay the bill. and then I'm good to go, right? I can immediately dismantle or remove that respective server, and that's it. So there is no liability, there is no legacy system, there is no purchase of a sub stuff, right? There is no upfront cost. So a lot of benefits you get it up, right? And then definitely for sure, I told you from $4,000, the dip is $20, or even I would say hardly, you know, even I've seen this case, $4,000 is actually the on-premises cost whenever you're setting it up. From 4,000, it's like $100. So see, there is a huge difference into it. Fine, and a lot of other benefits you get as well. You get a lot of functionality, you get better control over your respective data. Those kind of things you get it up whenever you're talking about switching to the cloud platform. Okay. Another thing is that, guys, you have the data security part. In this particular cloud platforms, you can encrypt your respective data. Fine. Whether it's in AWS, Azure, or the GCP. In the Google Drive, you particular put up a piece of an information, file or folder, and then you can encrypt it up. It's not like you have not done it. It's not even present there. So if you same applies with the OneDrive as well. If you go to the OneDrive, same problem there as well. You cannot encrypt your data. Okay, and the problem is persistent in other kind of storage devices as well, whether it's OneDrive, the Google Drive. Okay, those kind of things. So but when you move to this much more professional cloud vendors, right, where there is, and the different kind of vendors, AWS, Azure, the GCP, right, public cloud in place. In that, what you get is that you get a better control over your security. There what you can do is that you can create your own key, right? As I think you guys are aware about, in the encryption we have two type of keys: public key and a private key, right? We have public key and a private key. Fine. So these keys that we have created up, what will happen is that which is used for encrypting the stuff, I keep it up in my local system. Fine. I cannot share with anyone else. Like in the Google Drive, what generally Google says is that by default they will be encrypting at the piece of an information. Okay, fine with that. But the problem here is that the government can force the Google to decrypt the data and then read my particular data. So that I consider it as my breach of the privacy. But whenever you go to this cloud platforms, what is particularly AWS, Azure, or the GCP, in that particular case, what happens is that you have the power to create the keys. Correct? You what you do, you encrypt your piece of an information with that particular keys that you have created, and then those keys would be held by you, not by anyone else. That's the great thing. So if, let's say for example, the key has been created and that particular key is used to encrypt up a particular file. Let's say for example, tomorrow I delete this particular key. There is no other way you will be able to figure it out what particular piece of an information was present in that particular file. Clear? That's the thing. Another thing, the cloud you have that places, guys, flexibility. Based upon your respective requirement, guys, immediately you can deploy up a server, right? We call it by the name of auto scaling. Immediately the servers can be deployed up, multiple, if you have configured up, right, as per the increase in the demand. If, let's say for example, suddenly normally normal scenario, you have two servers, okay, which is able to handle up your respective traffic. But let's say for example, the number of traffic requests are increasing it up. So what you can do is that automatically the number of servers can be increasing it up to handle that traffic, but you have to configure it up. It's not by default, but that's the thing, you have to do it up. So that's the flexibility you have. Okay, another flexibility is that where you can create up a server which of any kind of a configuration you want. Like normally what you have is that in the laptops or at the desktop we have the configuration, right? i5 or i7, correct? And then you have 16 GB of RAM, which could be DDR4, DDR5. Then you have 1 TB of 1 terabytes of SSD or HSD, that kind of thing. So same kind of a flexibility you have over creation of the respective server, right? So the GCP also, when we will be doing up tomorrow's practical, in that particular practical, guys, we will be creating up a server, and then I will show you how much of a control I have over my respective server. I can choose my operating system, I can choose my hardware configuration without any second thought, right? It's very smooth, right? That's the case. Okay, so that's called the flexibility. As per your respective demand, you can create at the machine, and when your respective demand has been completed, your client is happy and its objective has been complete, you can dump that particular machine. You can just completely release it up and Then after that, there is no cost. There is only cost for the the resource that you're utilizing it up. Okay. Then you have what? You have scalability. Same thing, you can scale up as well. Okay, you can initially you can have two servers. You can increase it from 2 to 5 to 10, and after that what can happen is that you can decrease it back from 5 servers to 2 servers. So based upon your respective scenarios, you have this flexibility and scalability. You can scale the particular infrastructure as per the changing need, as per the changing need of the respective client in place. Okay, great. And you have the mobility as well. So what you can do, you can change your respective server. You can move your servers from one location to another one in place. Then guys, another benefit you have the cloud compute is enhanced collaboration. Okay, let me explain what this particular enhanced collaboration is. Let's say for example, there are two organizations. One organization, if this is present in United States, USA. Okay, you have another organization which is, let's say for example, present in Japan. Fine. Okay, if guys tell me, if these two organizations or two space agencies wants to collaborate together or do any kind of a work together, do you think it would be an easy task to do? Because two organizations are far apart from each other. So do you think it's an easy task to do? Is it easy to share the resources without including the cloud into it? Is it possible, guys? I mean, it is possible, but it will be easy. Absolutely not, right? What will happen is that, let's say, for example, there is a piece of a server in place. Fine. So the USA would be doing what? Let me just change the color of my pen. Okay. USA would be fetching up the data into that particular hard disk or storage media, and then through the plane, that particular piece of hardware would be moved to, or through the ships would be moving it to the Japan, right? There, definitely for sure, first of all, even the movement of that particular storage is costly, and there is a probability that something can go wrong. There could be cargo damage in place. Yeah. So that particular cargo storage you have in place, you have, moving up a server physically. Great. So that's definitely for sure. First of all, the risk increases up that there could be some sort of physical damage in place. Then what can happen is that, let's say for example, there could be mismanagement, right? A lot of things can be go wrong in that particular case. Whenever you are moving up a physical server from one country to another one, which will definitely for sure would be, at least 12 hours of a flight in place. Okay, so that's a little bit of a problematic thing we have in place. Okay, and it's costly as well. Imagine, so that particular server, after many days, lands into this particular Japan university or any kind of technical institute. Okay, great. Now what we'll do is that it's almost 5 days have been passed, and it has already cost them, thousands of dollars to just move the machine from one point to another one. And now what they will do, they will be correcting this to this particular machine. They will be looking to this particular code, that get to know that, okay, this there is some kind of a suggestion that I want to, you know share with my US clients in place. So again, they will be doing what? They will be changing this particular piece of a code, and again the same process again repeats. Again, through the aircraft or through the ships, it will be going to the United States. Again, they will be reviewing the codes, doing the modification, again shipping it back. So imagine a simple project, a simple launch of a satellite, or any kind of medical breakthrough they are working in, or nuclear physics, so any kind of a thing they are working on. It would be it will take a huge amount of investment, okay, which was absolutely useless. You're not actually investing into the research, you're just investing into this server moving from one point to another one, which definitely for could be accumulating a lot of an extra cost, which will be a lot of a burden upon the complete project. And it's definitely for sure, because a lot of time has been utilized in this particular case. So what happens is that it's just very much of time consuming. A small project would be, first of all, costing you thousands of dollars, and at the same time would be taking up a duration of at least a 1 or 2 years. So from a, this was the thing previously, when there was not much of in cloud, there was not, the internet was just starting it up. So this was the world before the internet. That's the reason, just internet has made our life such so simple. And let me tell you, when I include internet in this particular architecture, where the two particular services, two companies or two government agencies of different countries wants to collaborate together using up the cloud platform, how easily they can do it up. Okay, so let's wipe it up. Now again, this is the US server. a US company, right? And this could be a Japanese company. Like let's say for example, there's a collaboration going on between Tesla and Toyota. Fine. Okay. Now what happens is that instead of physically sharing the piece of an information, what they will be doing is that they will be creating up a centralized repository or centralized location where they will be fitting up their particular data into it. So what happens is that let's say for example, US client did some kind of configuration or change or any kind of a research, and he gets up a lead into it, he will be dumping that particular piece of an information into this particular private cloud. Again, this is not public cloud, it's a private cloud. You or me would not be able to connect to it. Fine. Okay. You put into it, it's like you can imagine like a Google Drive, but it's much more secure. No other third person would be able to connect to it. Then the Japanese people can go it up and read that particular documentation, improvement, changes, research, whatever things we have in place. Let's say, for example, the Japanese person wants to suggest something to the US client that, okay, if you do this kind of thing, your result would be improved. If you do this kind of, reaction or add this particular chemicals in place, your reaction would be increasing it up. It will be, the product would be much more stable. Those kind of. So imagine, first of all, it brings down the cost of the entire project drastically. You were previously spending thousands of dollars just to say the piece of an information. Now it is, I would say, in a week it could be hardly $100, $200. So there's a drastic reduce. On the second point is that there is no physical movement of anything. There's no cargo movement. There is no through the plane or through the ships. So the probability, the risk that it could be physically damaged or mishandled or lost, that's also completely eliminated in this particular case. Or it could be theft as well. Fine. So that's the thing. So improved collaboration. They can easily share the resources with each other in real time. And this particular session we are having it up is also one of the best example of what? The collaboration. We are all joined together. We are discussing a proper topic about the GCP. You are sharing your respective idea through the chat. I'm, sharing my respective idea through my respective voice. Okay. This is also a part of the cloud, right? And it's increase of the collaboration. Again, imagine a scenario where I have to just discuss you this particular GCP part and there is no cloud. Imagine how chaotic it would be, right? That's the thing. So that's why improved collaboration, a centralized repository you have in place where you can put up the respective data and someone can extract from it. That's it. Another thing, another benefit you have in place. Let's say, for example, tomorrow another company comes into it. Let's say, for example, in India we have the Tata. So another company comes into this particular picture and they also want to join into it. They also want to invest into this particular project or that vision these both companies are working upon, Tesla and Toyota. So what they will be doing is he will be also be third party, right? XYZ, any company, and he will be also the part of it. Fine. Simple as that. See how easily the particular third person was included into this particular or welcomed into this particular private cloud. So this is one of the benefits we have for cloud computing, right? Improved collaboration. Okay. Then you have other benefits as well, right? You have disaster recovery. If something goes wrong in this particular case, your data is present in the cloud. So guys, tell me, from the disaster recovery point of view, let's say for example I have two options. This is my PC, right? And this is a particularly a server I have in place. So what do you think? What's the best idea? Should I put this particular piece of a file, very sensitive information, in my personal PC or in the servers? So what we have in place is that if I put it up my particular piece of an information over the cloud, what happens is that even if, let's say for example, I lose the access of this particular drive, still my data is still residing over the servers in place. So what I can do, even in that particular case, I need only two things: my username and my password. I enter my username and a password, log into my particular Google account or any kind of an account in place. Let's say for example it's a private account, and then I through that I can fetch the data from that respective servers in place. Okay, that's the catch. Let's see, you have the data loss prevention as well because you're putting it up in the servers. Fine. Unlimited storage. As we move ahead in the session, I will be telling you that in the GCP also we just have this particular capacity in place. Like in the Google Drive, generally you will not be see this kind of a thing in place because there are a lot of limitations into it. But generally in the when we comes to the GCP, right, Google Drive, you can store petabytes of data. There is no limitation, but there is a catch till the time you are okay with paying with the fees. Yes, absolutely, Shantal. faster to access. That's also the very good point we have in place. So unlimited storage as well. You can have, let's say for example, you're working in an industry or an organization which generate lots and lots of data. So what will happen in that particular case? What will happen in that particular case? You can put or upload the particular petabytes of data, thousands of petabytes of data into that cloud platform. But definitely for sure, because you're utilizing the resources, you have to pay a price for that. Otherwise, you are good to go. Okay, great. So these are some of the benefit, guys, we have when we switch to the cloud platform, right? Okay, so like every technology, there is another side of the coin as well, the negative side, the disadvantage of doing for the cloud computing. So I have mentioned some of the disadvantages. Okay, very common and very important, which cannot be missed, because if you go by the documentation, if you go by the research paper, you there are thousands of disadvantages and thousands of pros as well. But I have limited, just limited to only five disadvantages what we have in the cloud part. The first is internet connectivity. Imagine a scenario where everything is working fine. You have your particular servers in place, right? You have your respective servers in place, your Google Drive, and you have, this is me. Okay, I have put up my particular data over the server. It could be Google Drive or any kind of a drive in place. But let's say for example, I am through my particular PC or my mobile phone connected to the server through an internet connection, guys. Fine. Okay, if there is no internet connection, if let's say for example this particular internet connection is gone, I am in serious trouble, right? If there is no internet connection, I am seriously in big trouble in that, because in that particular case I will not be able to make up a connection with that server where my particular file is present. Fine, that's the scenario. If I just give you a best example of this internet connectivity, has there been a scenario where you have visited up a hospital or a shopping mall or any kind of place where you do not have a cash, you open up your respective UPI, scan it up, and it says your bank server is down. So does that means that particular bank has been breached? Is it has faced any kind of a cyber attack? No. What happens is that there could be sometime there could be problems in the bank servers. It could be facing a lot of traffic which is not able to catch up to, and that's the reason it is overloading, and the performance is decreasing so much. That could be a scenario of a DOS attack, not exactly a DOS attack, but when the particular capacity of the server is almost fulfilled, so definitely a lot of problems starts to come to it. That could be also one of the reasons. Fine. Okay, another reason is that internet issue. Even if your server is absolutely working fine, your mobile device is also working fine, but the particular medium which is connecting your mobile phone to your respective bank server, which is the internet, due to multiple factors, due to climate, due to rain, lot of reasons, right? The signal capacity, the signals, the bandwidth drops. In that particular case, what happens is that your particular mobile phone, your particular application, your bank application is not able to communicate with the bank servers. In that case, so internet connectivity is a very core thing, very important thing when it comes to the cloud. Doesn't matter how secure the data of the customer is, that's also a thing. But if the customer, whenever he wants a particular piece of a data, is he's not able to access it up, that's a breach in its availability. We have in the cybersecurity a thing which is called the CI thread: confidentiality, integrity, and availability. So it's a breach in its third pillar, the availability part, right? So internet connection should be well established between the client and the server whenever there is a thing of the cloud or the cloud computing. Then there's, guys, something which is very interesting, and definitely for sure, if you go for the interviews, whether irrespective of the vendor, whether it's AWS, Azure, or the GCP, definitely for sure you are going to be asked this question of vendor lock-in, because that's a reality. We all face it up, right? What is actually this vendor lock-in? Vendor lock-in is same like importing, if you are aware about it. So in the lock-in, what happens is that, let's say for example, my organization says to me that, okay, Amit, right now we are going with the AWS. Fine. I just create up a server in the AWS and everything is working fine. Good security, good service, good cost, right? I'm not charged a lot. Everything is fine now. And it's, let's say for example, right now it's 2024. So what I do is that I would say more than 90% of my organization infrastructure is residing in the cloud, and particularly in the AWS. So I'm very happy with my particular provider. It's good security, everything is fine, right? Great. Good, good cost management as well. On a regular basis, I'm getting up suggestion policies. That how should I control my cost. That kind of cases in place, right? Good technical support. A lot of things I'm getting it up. Perfect. But let's say, for example, what happens is that after 3 years, 27 in 2027, okay, what I get to know is that my manager comes to me and says that Amit, you know what? Now AWS has become very pathetic, right? It's not up to the mark. It's not providing good resources. Security is lacking, facing a lot of breaches and all this kind of stuff in place. We are losing trust into it. So can we move our infrastructure of these services? Can we migrate our servers from AWS to GCP? Can we do that? So if, let's say, for example, when you are able to change your provider, you can migrate your resources from one point to another point. In that particular case, guys, what happens is that you say vendor lock-in is not present here. But when, let's say, for example, a scenario where you are stick with that respective vendor, when you cannot change your particular file, you cannot move your file or your architecture or your infrastructure from the AWS to the GCP or any other provider in place, you are stuck with the lender, no matter how worse that particular vendor is. That is called vendor lock-in. Even let's say, for example, on 2027, AWS increases the cost of the resources 3 times, but the services has becomes more pathetic. So still in that particular case, you have to stick with the vendor because it would not let you migrate its services to other cloud platform. That is called the vendor lock-in. And whenever you're working in the multi-cloud environment, when inside the organizations, half of the infrastructure in the AWS, half of it's in the Azure, and rest half of it's in the GCP, and some else in other kind of, I would say, Oracle or Alibaba or something like that. Okay, that's the case. So in that particular scenario, you will be coming up across a scenario where you cannot migrate your resources to any other cloud provider. Fine, that's the case. That is called vendor lock-in. Now you have two choice: either completely dump that particular server and create up a fresh server in the GCP. That's the only solution you left with when it comes to vendor lock-in. Okay, so keep this thing in mind whenever you're using up a service. Nowadays it's very rare. I would say yes, nowadays generally whenever you go to the any cloud platform, whether it's AWS, Azure, GCP, Oracle, Alibaba, whatsoever it is, definitely for sure by default now they are much more open to other cloud platforms. So AWS gave this particular functionality that you can migrate to the GCP, to the Azure, and this kind of things in place, right? So nowadays they are more open to other cloud platforms in place, correct? That's the thing we have, Selva. Okay. So previously this was a scenario, because remember it up, this was a problem. This was the problem the developers, the cloud engineers were facing it up a lot. Way back, I would say in 2010 and 11. After that, the different vendors have removed these kind of barriers where you cannot move your respective VMs from one vendor to another vendor, and that has given the birth to multi-cloud. That's the reason this vendor lock-in has decreased. They are now open to it, and nowadays many organizations are becoming or using a multi-cloud where some of the servers are running in the AWS, a load balancer is running on the GCP, those kind of things in place, right? Okay, great. Then you have another thing, another disadvantage of the cloud computing, which is limited control. So what is this particular limited control? In this particular limited control, guys, the problem here is that you have does not have a direct control over your respective data. Let's say, for example, whenever you're using up your Google Drive in place, guys, okay, and you're putting up your particular file or any kind of pictures or any kind of information over the Google Drive, do you have any kind of a control where actually in that particular entire globe where your particular piece of information would be stored, guys? Is that you are a client, okay, you've put up a data over a Google server using the Google Drive, right? But this particular server, guys, can be present in United States, it could be present in Canada, it could be present in Japan, it could be present in Brazil, right? So what happens is that a physical server which is present in Brazil holds up a data of an Indian citizen, right? From a security point of view, that's not a great thing. Okay. Yes, correct. Right, correct, Dinesh. Okay, so that's the thing. So we have very limited control over the respective data in place. So whenever you move to this particular cloud platforms in place, whether it's a GCP, AWS, Azure, in this particular case, not the Google Drive, I would say. Okay, because when it comes to the public cloud, we also have the subcategories there: personal level public cloud and organization level public cloud. Okay, so at a personal level public cloud like the Google Drive in place, you have no control over the data where your particular piece of information is present. Okay, yeah, Selva, we can set up, right? Okay, and I would say in organization level public cloud like the AWS, Azure, and the GCP, you have better control of your respective data in place. Fine, that's kind of thing. So that you have very less control of your respective data. Okay, then comes the security part as well. Okay, so like in the same case in the Google Drive. So guys, in the Google Drive, as I asked you this question again in the session as well, that you does not see anything, to encrypt your piece of an information, right? You does not see any kind of a thing to encrypt your particular piece of an information, guys. Okay, so that's a kind of, a big problem from the point of view of the security. It's a very very concerning thing you have in place, right? Okay, so because the keys are there, definitely if you go to the Google or search through the internet, you get plenty of articles in place which says that Google by default encrypt your piece of an information. Great, but that particular keys that are being generated, that are not provided to you, so that are present by the Google. So what can happen, if Google want, they can grab your keys, and what they can do is that they can access your respective data, which many security people claim that Google is doing it up in the backend. Okay, and based upon the data that you're dumping it up in the Google Drive, they are then analyzing it up and then bombarding you with that respective topic, okay, or the advertisement. I would say, Selva, see, when it comes to the security across the vendors, they have different ways to control the, this data leak or data access, right? They have different mechanism in place. So for all the cloud vendors, it's not the same, I would say. Everyone takes up a different approach. Fine, that's the case. Some would be allow some would be making it very difficult to share the resources with someone else. Some allows, to have a very using up a very good encryption in place, those kind of thing. Okay, that's the case. But remember it up, every so see problem, everyone, whether it's AWS, Azure, GCP, irrespective of the vendor, everyone has the same problem. Fine, but because they are different organization, their tackling that, how would they tackle that particular problem is different. GCP use different kind of an architecture to make the data more secure, good, using good latest encryption algorithms, right? Allowing you to have the keys in place. Azure uses some different kind of a mechanism in place, and AWS has a different mechanism. So definitely security is a very very important thing, but there are features particularly in these vendors in place. If you use them correctly, it, trust me, it increases your security and take it to the next level, right? That's the case. Okay, so you should have a good understanding how those things are in that particular part. Okay, then you have, guys, another thing which is called by the name of multi-tenancy. So there are two terms, guys. One is called single tenant or single tenancy, or multi-tenant or multi-tenancy. Okay, now this is the one of the biggest reason multi-tenancy, that why cloud is so cheap. When I'm going to the on premises and I'm putting up an upfront cost of thousands of dollars, okay, in that particular case, when I'm setting it up, I'm setting it up for my own organization. If, let's say, for example, guys, tell me, if I'm setting up a private cloud for my infosec train, so will be open for everyone? Do you think that? Will it will be open? Absolutely not. It will not be. I will be spending lakhs of thousands of dollars to build up a private cloud, and it will be definitely for sure to resolve the issues, to store the data, all these kind of things, right? Of the customers, clients, of the trainers, and all kind of things to make our life much more easier. But related to the stuff or the activities or the issues of the organization only. Absolutely correct. It's not fit for the purpose. Perfect. That's what the private cloud is for. Cloud is for resolving your private issues. It's not for the allowing public people to have it access to it, right? That would be a public cloud. Great. So that's the thing we have. So in that particular case, in the private cloud, what I'm doing is that I'm creating up a stuff. I'm building up an infrastructure for me, for my organization. Fine. In that particular case, the security is good because only the control people or only the knowing beings could be able to use it up. But the upfront cost, the actual setup is going to be huge. That's the case. But that is called single tenant. When a piece of an hardware is being provided to you only. Let me just tell you what a single tenant is, then I will be coming to the multi-tenant. This is a very important thing, right? That's the reason, irrespective of the vendor, everyone, that your cloud is so low. The kind of, I would say, the deployment of the server, whether it's a GCP, Azure, AWS, Oracle, whatsoever it is. This is the reason multi-tenancy is that particular reason why cloud is so cheap. Okay, so let's say for example, this is a particular piece of an hard disk of 1 TB, right? Okay, let's say this is Ganesh, right? And Ganesh makes up a request to this particular 1 TB. So what happens in the single tenant, guys, is that this particular person A, Ganesh, would have a control, complete control over this 1 TB of hard disk. That is called single tenant. Only one individual is having an access of only one resources. Fine. So what he can do, he can put up a sensitive information, personal file into it. Fine. And whenever he needs, he can fetch it up. No problem with that. Clear? Okay, he's not sharing this particular hard disk, virtual hard disk, in the terms of cloud, because there is not a physical hard disk that is actually you're having. You're actually having a virtual hard disk. So that particular virtual hard disk, a particular piece of hardware, you are not sharing with anyone else. See, Selva, we can put up one individual or one firm, no problem with that. Let's say for example, if I just say, let me just change it a little bit. I can say uh, 1 terabyte. Okay, two scenarios could be, oh, sorry, my bad. 1 terabyte. Okay, and let's say for example, when it comes to single tenant, in that particular case, what happens that this can be me, okay, or people of my organization. This could be my colleagues as well, C1, right? We will be using this particular hard disk. Okay, that's the thing, right? This is called single tenant. But generally what we have in place is that, so what you can do in this particular single tenant, the piece of an hardware can be accessed by one single firm or an individual. But generally when we comes to single tenant, we say that the piece of an hardware, one single piece of an hardware, is managed by one person. Okay, that's the case. Fine, great. So that is called single tenant. One individual is able to access up a hardware, a piece of an information. It's not being shared by anyone else. Fine. Okay. Then we have something else which is called, guys, by the name of multi-tenancy. A multi-tenant. It means that a piece of an hardware is being shared between multiple people. Let's say, for example, this is a piece of an hardware which is of 1 TB combined, and it has what? It has four fragments: A, B, C, and D. What happened in that particular case is that, yeah, what happens is that this is me. Okay, I will be able to have an access to this particular drive, I would say, right? And putting up my particular piece of an information, sensitive information, into it. This, there could be person second P2, he would be having up or putting up a particular piece of information here. There could be another person P3. So see, hard disk is there, but there is a logical partition being set it up. Like normally we have a logical partition in our systems. Like we have the C drive, E drive, which is not physically part division, is there? So, but what's the problem with that, guys? What do you think? What's the problem in this particular multi-tenancy? Definitely, for sure, it brings up the cost a lot drastically. But both has its pro and cons. If you go for the single tenant, definitely that particular case, what happens is that you are assigned a piece of an hardware. You can access it up, okay? In that particular case, because you are the only person accessing that 1 TB of an hard disk, so in that particular case, you will be the cost would be much. Clear? Okay. But what happens in that say in that particular scenario or that particular scene is that the security is very good. But in this case, what the problem? What's the biggest problem you have? In the multi-tenancy, the advantage is that the cost is drastically reduced because now let's say for example, this 1 TB is costing you how much? $500. So it will be broken down between 4 people. Okay, that's the catch here. So the cost is decreased. That's I would say the benefit we have. But uh, from security point of view, it would be a it can be a problematic thing. It's definitely for sure there is a probability that sometimes things can go wrong into it. There's something which is called by the name of VM escaping. Security. Yeah, so definitely see, Ganesh, definitely there could be security problems if there is data, there is a partition into it. What can happen is that there is a phenomenon which is called by the name of VM escaping. What it means is that, let's say, for example, you have a particular piece of an hardware, it's been broken down into 4 partitions. Fine, this is me. Let's assume I'm a hacker, right? I teach ethical hacking as well. So what I do is that I'm aware about, you know, um, the malware and all this kind of stuff in place, right? So what I do is that and this is another person which is having it up, P1. This is another person, P2, I would say, which is having it up, P3. What I do intentionally or accidentally, I upload up a piece of a file into this particular segment, okay, which contains up a file which contains up a virus. So I'm not aware about that it contains up a virus. So what will happen in that particular case is that the virus can jump the partition from my system to this particular P1 or to this P3 or to this P2, and trust me guys, it would be a disaster, right? One person did up a mistake, it leads to a creation of something which is called VM escaping, where the virus or the file is able to jump the partition, the logical partition, and land into another segment of the partition and infecting that as well. That would be a very, very problematic thing. Fine. That's the catch we have in there. That is the problem with the multi-tenancy. So multi-tenancy, I told you, from a security point of view, it's not a great thing. But always remember, whenever you're using it up, this Google Drive, actually in the backend, you are using up the multi-tenancy. That's the reason it's so cheap. Okay, or generally the cloud, whether it's AWS, Azure, or the GCP, in the backend also, that's the reason what is actually happening. It is that that's the biggest reason why the cloud is so cheap. Instead of having a upfront cost, and so guys, this is called the multi-tenancy, where you have a particular piece of hardware which has been divided among multiple people. There are multiple partitions into it, A, B, C, D into it. Okay, clear. So yes, we can. Great. So guys, this was some of the disadvantages in the cloud computing. Okay. So guys, now let's talk about different kind of vendors of the cloud. So these are the top three different kind of vendors we have in the cloud part: AWS, Azure, and the GCP. Clear? Okay. So we are going to stick with this particular part, GCP, right? Okay. So in the coming days as well, from tomorrow onwards, we are going to do a hands-on practical with this particular GCP part. So guys, do not miss tomorrow's session, because I will be making you familiar with the GCP environment, how things are there, how do you configure things, how do you make up a connection to us, how do you first of all launch a server in the GCP, okay? And then what you do is that how to connect to that particular server in place, right? So I will be generally showing you up how to create up a Windows server, and then using up the RDP protocol, we will be able to make up a connection with that. Fine, that's the thing, and we will be able to have host up a web server into it. So those kind of an activity, those kind of hands-on thing, I will be doing it up as well, which you can replicate after, I would say, the session has been completed in your live environment, right? Now, guys, let's talk about different kind of cloud deployment models we have in place, right? We have the public cloud, we have the private cloud, hybrid cloud, community cloud, and then we have the new kind of deployment model in place, which is called the multi-cloud in place, right? As I told you about, as the time progressed further and this particular vendor login problems decreased, and now the different vendors were now open and able to communicate with each other, build, that's the reason many organizations now start adapting multi-cloud architecture. That's the thing. So let's talk about this particular cloud, different kind of cloud deployment model. So the first one is called the public cloud. Public cloud, guys, means that it is available to the general public. That's what it means. It is available to the normal general public in place. Fine. Okay. So the best example of the public cloud would be AWS. Yeah, correct. Multiple client could access them as well. But I would say this particular feature is also present. This multi-client access, I would say, yeah, it's correct, but it's not a specific identity. Okay, this is not a specific that is only present in the public cloud. Okay, but yes, it is there. Multiple clients can access it up. Same, this particular rule would apply in the private cloud as well as in the community cloud and the hybrid cloud. Okay, but the unique property, the characteristic property which separate the public cloud from the rest of the cloud deployment models is that the public cloud can be accessed by the normal public in place. Okay, like you have the AWS, Azure, the GCP. As I will be showing you tomorrow in the session is place, what happens is that you will be, you know, um, you do, irrespective of who you are, right? Which kind of profession you are in. Fine, you are in sales team, you are in marketing team, you are in DevOps team, you are just starting it up with the cloud part, you're a software developer, you're a network engineer, irrespective of which kind of platform or which kind of job role or the history you have in place, occupation you have, you can go to the particular cloud providers and make up your respective account and use up the respective resources. But the catch here is that in that particular scenario, the interesting catch you have in place is, I would say that if you are okay with paying up the bill, then fine with it. Okay, because at the end of the day, you are renting up the stuff of the cloud provider, and at the end of the month, you have to provide up a charge for that. Okay, that's the thing. That's the public cloud. So public cloud, you can also, just you does not need to memorize anything. You can just connect things. So I would say, or relate things. So I would say public cloud is like your public vehicle. If you just go it up, there is trains, right? Okay, that's a public property, that's a public means of transport. There are buses in place, right? Okay, for local communications, uh, right? So those kind of things we have in place. So do we rent them up? Do we rent the railways, right? Do we rent the trains? Sorry, do we own the trains? No, we do not. What we do is that when I want to move from one point to another one through a train, what I will be doing, I will be reserving up my respective seat, and I will be paying up a very small amount for that. Same applies to the public cloud. You does not own the cloud, but what you do is that whenever you want to use the services, what you do, you just rent the stuff from it. Fine. Now what happened, guys, in this particular case is that, yeah. So what happens in this particular case is that, uh, okay, great. So what happens in this particular case? So public cloud is like anyone can use it up, and in that particular case, what happens is that you are, you know what, you are renting the stuff and paying up. That's called the public cloud. Then you have another category, guys, which is called by the name of private cloud. So what actually this is private cloud is all about? The private cloud means that it's your private property, it's your private entity. Again, if you want to relate, if you want to remember this private cloud, remember private cloud as your private vehicle. Okay, definitely for sure, if you purchase it up your own private vehicle, there are pro and cons for that, right? So private cloud, it's like your private entity, your private vehicle. Okay, So what are the pro and cons for that? The advantage, guys, for this particular private cloud, the advantages I would say first is that of the security, you are not sharing this particular piece of an hardware or the infrastructure with anyone else. That's the one thing, right? So security is one of the best example you have for one of the advantage I would say. Okay, that's the case. Fine. So that is one of the advantage you have in place, that you control of your respective data. There is a transparency that how good your respective data is being controlled, which kind of encryption is being used, how the keys are being stored, how the keys are being shared, who can access your respective data. Like same kind like your respective car. Whenever, let's say for example, guys, at the time of COVID, if you guys have two options to go using the public transport. So guys, at the time of the COVID, if you guys given up this particular choice, that do you want from your respective house to the office, right, using up the public vehicle or your private car, what would you choose? If you're using up a public cloud, because it's been owned by or it's been used by multiple people which are even outside of your organization, so you cannot do a background check, there is not proper security control into place, there's a possibility that you're sharing of the resources with them, thus you're sharing of the hardware with them. If anyone intentionally or unintentionally upload up a file which have a virus and the virus jumps from his partition to your system, you are in serious trouble. But in the private cloud is its own property. It's like your own private vehicle. Like what happens is that if I just want to go from my house to my office using my car, the probability is that I'm secure. Same here with the data as well. Whenever you have the private cloud, you are more secure because you have a better control over your respective resources. But the disadvantage with the private cloud, guys, is that it is expensive. Fine, you are building up, you are creating up your own infrastructure. You have to pay thousands of dollars to build it up, to have a servers and all kind of stuff. Then you have need to have a team in place. If let's say for example things goes wrong, there is a problem there, there should be some way that what should I do in order to resolve issue. There could be a data breach, a lot of things that needs to be done there, right? So a lot of cost would be there included there. So that's the reason it could be expensive. So that's called the private cloud. Okay, your private property. Then guys, you have another one which is called by the name of hybrid cloud. So it's a very simple and easy to understand definition of the private hybrid cloud. Hybrid cloud, guys, is the combination of public and private cloud, right? That's it. Okay. Then, guys, we have something which is called by the name of community cloud. So, community cloud means that, guys, you have people coming together with common interest. Okay. Let's say, for example, there are uh, three banks that wants to come together to build up a community cloud. So remember, community cloud, it's a much more advanced version of the private cloud only. If you understand private cloud, you understand community cloud. That's it. Okay, let me just explain you what a community cloud is. Let's say, for example, you have need to have community. It means people with common interest, right? Let's say, for example, there are three banks. Okay, so guys, there is a specific kind of data the bank hold, which is called by the name of PII. PII, personal identifying information we have in place. Very, very sensitive data, name, address, social security number, okay, telephone number, all these kind of things comes under the PII. So definitely for sure, whenever you go and create up a bank account, banks collect a lot of information about you to do a background check, to find out that okay, you are a legitimate person, all this kind of stuff in place, right? So definitely, so the banks always fear that this particular PII should not be in the wrong hands, right? So community cloud means that, guys, let's say for example there are three banks, one, two, and three. Okay, this is bank one, this is bank two, and this is bank three. So three people. In cloud deployment model, what we have is places that let's say, assume three individuals. You can have more than that as well, no problem with that. What they will be doing is that they are fearing it up that if we go to the Google Drive or if we go to the AWS, the problem in that particular scenario is that I am sharing the particular piece of an hardware with multiple people. There's a problem of multi-tenancy, right? So to resolve this kind of an issue, what happens is that they came up with an idea of setting up their own private cloud. Let me set it up. They are setting it up their own private cloud. Remember, this is what? This is your private cloud. Okay. So what will happen in this particular case? What the thing is that, let's assume the normal setup of this particular private cloud was $1,000. But because now three people are managing this particular private cloud, let me just connect with it as well. Okay, not see, this is not the correct one. Yeah. So because three people are now connected with this particular private cloud, right? This $100 or $1,000 would be segmented between three individuals. Fine, that's the catch. So one, two, and three. So so you get the best of the both world. First thing is that it's a private cloud that no one else other than the three organization would be able to make up a connection with this particular cloud, so their data is much more secure. Another thing is that the cost of setting up of running this particular server is $100, $1,000, whatever it is. It will be divided between these three entities. So you get the best of the both the worlds, right? Normally, what's the problem with the private cloud? The private cloud, the problem was that the cost was much. Even if the security was you were getting it up was great, it was fantastic, but the price was high. But in the community cloud, they came up with the solution of that as well. What they did, if the cost is $1,000, $2,000, whatever it is, now it will be equally divided among the four or five or how many entities they have in place. So that at an individual level, each bank, this particular one, would be paying less price but get a much better security. Okay, that is, guys, what's called the community cloud. Fine. Okay, then you have another type of cloud in place which is called by guys by the name of multi-cloud. So what is this actually a multi-cloud you have in place? This multi-cloud, I would say, this multi-cloud, it means that, yeah, it means that half of your infrastructure, let's say for example, this is an organization, right? Instead of just relying upon only one organization or one cloud vendor, what they do is that they just divide or segment their infrastructure into multiple partitions. So let's say, for example, one of the or two or three servers are lying in the AWS, then half of it's running in the Azure, right? Easy, Azure, and another one are running into the GCP. So that is called by multi-cloud. When half of the infrastructure is in the AWS, half of it's in the Azure, and half of it's in the GCP or some, and half of it in some other cloud provider. So okay, so you are doing what? You are using the best of the both world. If let's say for example AWS give running up a server in the AWS is pretty cheap, what will you do in that particular case is that you're running a server in the AWS. If let's say for example hosting up a database in the Azure, it's quite cheap, flexible, and secure. You are hosting up the database in the Azure. Let's say for example building up you know any kind of a key or encryption or any kind of storage place, right, which is having a better control, flexibility, and security. It's good in the GCP. You also, so you're dumping up your respective data to provide a better level of security in the GCP. So that's the way you're looking at what's good in each one of them and utilizing all of them at a time, right, or all together. That's called the multi-cloud architecture. Okay, guys, got that clear with it? So guys, now let's talk about cloud service models, right? So generally what happens is that in the AWS, whenever, or in the AWS or the GCP or the Azure, different kind of services we have in place, right? So some of the services could be called as IaaS, PaaS, and SaaS. So these three are very important, and let me break it down for you what they mean: IaaS, PaaS, or SaaS. Here you can see that this the catch. This is the on-premises one. See these things. These are the important, guys, building blocks you have in place. Okay, you can see application, data, runtime, middleware, operating system, virtualization, server, storage, networking. All of these components you have in place. And remember, these components remain the same irrespective of whether you are building up the infrastructure in the on-premises or over the cloud. It doesn't matter. Infrastructure is always going to remain the same, right? If you deploy up a server or run up an application over a local system, it will be utilizing the same thing. If you run it over the cloud, it will be utilizing the same thing. The infrastructure remains the same. The problem here is that where actually are hosting it up. That's the big catch. Fine. So in the on-premises, guys, what happens is that, as you can see, all the elements, all these basic elements, you can have more than that as well, but these are the basic fundamental components that are needed to have a good functioning working infrastructure. So in the on-premises, everything is being managed by you, like the network, like the storage, like the server, virtualization, operating system. Everything, guys, is being managed and taken care by you. So if, let's say, for example, if there is any kind of any sort of cyber attack happen, you are responsible for that. You have to mitigate it. You have to resolve it up. That's why I told you that whenever you are putting up a server, you have to also think about managing and maintaining up a team in place. Fine, that's the thing. That's the problem with the on-premises one. Then, guys, we have another model, particularly which is very famous, which is called by the name of IaaS, Infrastructure as a Service. So, guys, any idea what is this IaaS is? So, in this particular IaaS, Infrastructure as a Service, as you can see by the diagram by itself, it says that some of the partition. Okay, infrastructure service means that I would say it's a 50-50. The elements, the components that you're seeing in the red, virtualization, server, storage, networking, all of these components are being managed by your CSP, cloud service provider. So, right? So, what happens is that if there is some kind of a problem going on with my respective server, my cloud service provider will be looking after that. If, let's say, for example, there is some kind of a problem going on with my storage, my cloud service provider will be looking after that. Fine. Networking, if, let's say, for example, there is a problem going on with my routers, configuring it up, troubleshooting, all the thing, my cloud service provider will be looking after that, not my headache. My headache is that all these components, these one, which are in blue, right? Managed by you. My operating system, middleware, runtime, data and application is my responsibility. So if let's say, for example, there's a problem going on with my respective operating system, I will be responsible for that. Okay. That's called in the IaaS, infrastructure as a service part. If that's, let's say, for example, there's a problem with my application, there's a vulnerability, it's my headache to resolve it out, to mitigate it up, to patch that particular vulnerability. Then you have, guys, something which is called the PaaS, platform as a service. Okay, in this, as you can see it up, all the components, I would say 90% of the component is being managed by your cloud service provider. The runtime, middleware, operating system, virtualization, server, storage, networking, everything is being managed, maintained, and secure by your cloud service provider. You does not need to worry about anything. You just need to about only two component: application and the data you have in place. Correct? Application and the data is the only component you have in place. You have to worry about in the platform as a service model. So generally, I would say the developer services comes under the platform PaaS services, right? Let's say, for example, if there is a development service in place where the developer would be going to it, whether it's AWS, Azure, GCP, they have different kind of services in place. So what happens is that they will be going to it, and then what happens is that they will be, they will be putting up their respective code. Fine. Thus, the data is managed by your respectively cloud service provider. Okay. Sorry, the data is being managed by you, not by a cloud service provider. Fine. Okay. Great. The storage of the data is managed by the cloud provider. So let's say, for example, the data creation and all those kind of things you have in place, but how the data is being stored, where actually it's being stored. Let's say, for example, in order to make the architecture much more resilient, what can happen is that a copy of the data can be present in one region, and on the another region a duplicate copy could be present, right? Those kind of things. So if this goes away, the original copy goes away, still you have the duplicate. Those kind of things. Fine. Okay. So in the platform PaaS, what happens is that you allow the developer to build, deploy, and manage application without worrying about the infrastructure. Okay, that's the case. Great. Then you guys, you have the SaaS, software as a service. So in the software as a service, guys, you have all the elements being taken care by your cloud service provider. Fine. Just best example, if I just tell you of the sort of software service is that of the Instagram. So guys, in the Instagram, can you change anything? Can you change its operating system of the server of the Instagrams? Can you change that, guys? Can you do it? No, right? Okay. Can you change the data of the Instagram? How the data is being stored? Which kind of encryption algorithm is being used? Those kind of things. Can you do that? No, right? We cannot. We cannot do anything. We just install that application. We do a little bit of an interaction with that. That's it. We do not do any kind of change into it. We cannot change the operating system. We cannot change the virtualization, storage, networking. We does not have any kind of a control into it. And those kind of services, guys, is called software as a service. Fine. Okay, great. Clear, guys? Any doubt? Any question till here? Great. So, guys, move to the next topic: service level agreement. So, what is the service level agreement (SLA)? So, guys, service level agreement, is in the particular in the context of the cloud is a contract between the cloud service provider, your CSP, and the customer. And what happens in that particular case is that it defines the term, the condition, the performance metrics, right? The responsibility. Okay, who is responsible for what? Okay, that kind of things we have in this particular service level agreement, SLA. So it's what it does is that it help you establish expectation regarding the quality, availability, and all these kind of things. So let's say, for example, in the service level agreement it will be written it up like in this case, if it is a pass service, in this case the application and the data is the responsibility of the customer. Fine. Other thing would be the responsibility of your cloud service provider. It will not be your responsibility. Okay. So what can happen in that particular case? If the cloud service provider has said that they will be taking care of your respective data, and tomorrow you faces up a data breach based upon that service level agreement, you can drag that particular cloud provider to the court of law and say that judge, that what, that this particular person has said me that he will be taking care of my respective data, but I have now witnessed up a data breach and my data has gone. So he is that particular person who has not able to fulfill that respective duty. That is called service level agreement. So there is an agreement between signed between both the parties, right? So well, okay, that's the catch. In this, let's say for example, if it is IaaS, in that particular IaaS, what happens is that, let's say for example, application is in your control. Okay. So let's say for example, my application is hosted up and it faces this kind of an SQL injection attack or web application or yes, correct, was okay. Yes. So cross-site scripting and all this kind of things. Okay. What can happen is that, let's say what happens, I drag my cloud service provider with the AWS, Azure, GCP to the court of law. Okay, so judge sees that particular service level agreement and says that, Amit, you know what? In your service level agreement, the cloud provider has already mentioned it up that the application is your responsibility. So if there is a SQL injection attack or a cross-site scripting attack, okay, or a broken or any kind of an web application attack in place, it's now your responsibility. It's not the responsibility of the cloud provider. So in that particular case, cloud provider has no responsibility in that. Okay, it's my responsibility. So that's the thing. That's what we do in the service level agreement. We create up a agreement upon whose responsibility is what. You protect my application. I look after my operating system. All those kind of things in place, right? So it's give it up a better clarity and from a legal perspective as well. A lot. If let's say for example a data breach happens into it, definitely in that particular case, what happens is that you can drag to the court of law, and the judge also has a better clarity that whose responsibility was what and who is that particular individual, whether cloud provider or the customer, who has failed in his respective duty. Okay, that's the case. Clear. That is called the service level agreement. This was for today's session, right? And in the chat, guys, I'm pasting up my LinkedIn profile. If you want to connect with me, you can paste it there, right? You can connect me there as well. And guys, from tomorrow, please do not miss tomorrow's session. It will be much more practical as well. Okay, that's the case. Fine. And you can just after the session, you can just revise it up. You can create up a server and all kind of things. And please. So bye everyone. Bye. Take care. Good night. And let's meet tomorrow. where we will be digging deep into this particular GCP infrastructure, creating up a server, learning about machine instance, all those kind of things. So, guys, I have pasted up a link for my ID of my LinkedIn profile. You can just click connect me there as well. Okay. Any doubt, any question, to any kind of a certificate, whether you want to switch from AWS Azure to the AWS to the Azure, the GCP, we can have a discussion there. Okay.